Hi everyone, we will solve the problems about derivative. So here we have the first question, which is about the formal definition of the derivative. So we will use this definition to find the derivative of the given functions. So for the first part, we had this function, so we just apply this limit, we just compute this limit, sorry. We just put x, instead of x, we plug x plus h, okay? So here we have 1 over square root of x plus h minus 1 minus the same function over h. So what do? We multiply this by this one's denominator and multiply this by this one's denominator. Hence we have this, okay? So to find this limit, we multiply and divide it by the conjugation of this. So we have this in the numerator and the same in the denominator. We multiply these ones and get this in the numerator and in the same equation in the denominator. So here in the numerator we get minus 1, okay, because we simplify them, and we simplify these h's and get minus 1. So here we have minus 1 and the same again in the denominator. Now we put h equals to 0 and here we have zeros, okay. So here we have minus 1 over square root of x minus 1, square root of x minus 1. So we have this, and square root of x minus 1 plus square root of x minus 1, and we have 2 square root of x minus 1. So we have this. Thus, the derivative of this function is this, just by using this definition, okay? So what about this part B? Again, we'll apply the definition. So we put x plus h instead of x here in the function. We have this. This is the same with the function over h, okay? So for this, what do? We again multiply this by this one's denominator, which is x plus 4, and we multiply this by x plus h plus 4, okay? So we get these ones, okay? And here we have x plus 4 times 2x plus 5. We multiply this by first this part, then this part, to have something easier, okay? So we have this, and then we multiply this with this x plus 4, and then h, okay? So we have these ones. Now these are the same with the opposite signs, so we have 0, and this one, so we have this, okay, which is exactly this numerator. So in the denominator we have all the same. So we simplify these ones and get this, and now we have, you see, we have 2x minus 2x, so we have 7 over this. Now we just put h equals to 0 and get this. So this is the derivative of the given function. Now we will find the derivatives by just using the rules, okay? Remember, if we have a function of this form, x to the n, then its derivative is n times n, sorry, n minus 1, okay? N times x to the n minus 1, okay? So here we have 5 times x to the 4 and minus, here we had 3, we multiplied by 3, so we have minus 9 and x squared. This is constant, right? If we have a function which is constant, c is some real numbers, then its derivative is 0, okay? You can see here as you have x to the 0, right, which is equal to 1, and you just apply this rule, so you have 0 times c times x to the minus 1, so you have 0, okay? You can think it like that. What about here? We rewrite the given function 6x to the 1 over 2, okay? And we apply the rule 1 over 2 times 6x to the minus 1 over 2, because we write n minus 1. So we write this is 1 over 2 minus 1, okay? Times this one's derivative, which is 6, okay? So we have this. So, you know, we have 6x to the minus 1 over 2. So you have 1 over square root of 6x. And we had before 1 over 2, as in here. And here we have 6. So we simplify them and get 3, okay? Oh, sorry, I made a mistake there. So this will be in the numerator. 3 over square root of 6x, okay? Here we have a product. What's the rule? If you have this, then its derivative is equal to this. F prime of x, which denotes the derivative of x, plus f of x times g prime of x. Okay, we just applied these rules. You know already how to take the derivative of this one. So you write minus 3 x to the minus 3 minus 1, which gives you minus 4. And this one's derivative is already 0, so you just write the second function, which is x to the minus 2 minus 5x plus, as in here, and this first function times the second one's derivative, which is this, okay? And the rest is easy. You just operate, you just add or subtract, so you have finally this one. What about quotient? So if you have some function like this, its derivative is this, f prime g of x minus f of x times g prime of x over g squared x, okay? And remember, the derivative of cosinus x is minus sinus x, and the derivative of sinus x is cosinus x, okay? So what's the derivative of x? It's 1, and you write the second function minus x times the second one's derivative, which is minus sinus x, over cosinus squared. So you have this, okay? You have second and tangent here. You can just write the definition of the given functions. So you know this can be written as 1 over cosine x, and tangent is sine x over cosine x. So you just, to find these ones' derivatives, you just apply the quotient rule, okay? And the rest is easy. So what's the derivative of this? It is sinus x over cosine x, as we did there. You just, instead of x, have 1, okay? And we have tangent here, which is sinus over cosinus, plus 1 over cosine x times this one's derivative, which is first one's derivative cosine x times the second one cosine x minus first one sine x times the second one's derivative, which is minus sine x, over cosine squared. Okay, so you have here sine squared over cosine to the 3 plus, here you have cosine squared minus, sorry, plus sine squared, okay, over cosinus to the 3. This is equal to 1, remember this identity. So you have 1 plus sine squared over cosinus to the 3. What about this? Now you have 3 functions, but you can see this as you have 2 functions. So you can consider the first one as the first function and cosinus sinus as the second function. So what you have, you need to take the derivative of the first one times the second one plus the first one times the second one's derivative. So here you have 2x as the derivative of this function times cosinus x times cosinus x plus x squared times this one's derivative. So first one's derivative times the second one plus first one times the second one's derivative, which is cosinus x. So you have this. Now this is equal to this parenthesis here, cosine squared minus sine squared. Remember, this is equal to cosinus 2x, okay? We did that in the first class, I guess. So check these ones, these identities. And here you have 2x cosinus x sinus x. Remember, sinus 2x equal to 2 cosinus x sinus x. So you have this. Now, finally, you have x sinus 2x plus x squared cosinus 2x. If you want, you can write in this parenthesis here. What about this? This function does not depend on x, so it's constant. So as I said before, its derivative is 0. And this, first rewrite this function, okay? Because it's hard to find its derivative as with this form, okay? There will be so many operations needed, so let's rewrite this as in this form. Okay, you just multiply them. Okay, so you have this. Now we apply the quotient rule. So here we have 2x plus 1 as the derivative of the first one times the second one minus first one times the second one's derivative, which is 2x minus 2, okay, over the square of the second function, okay. So you just multiply these parentheses, okay, and finally you add them and get this quotient. This part is easy. So the trick is here, rewrite the function as in this form. What about this? Again, we can write this one as in this form. So here we have square root of x over, we rewrite this first, x squared plus 4 over x, and finally we have this x times square root of x, How can we write it? So for the numerator, we have this actually. X square root of x, x times x to the 1 over 2. So x to, this is 1, 1 plus 1 over 2. So it's x to the 3 over 2, okay, over this again. So how do we derive? Again, we apply the quotient rule as with this function. This is the first function and this is the second function, okay. So the first one's derivative is 3 over 2 times x to the 1 over 2, because here you have 3 over 2, okay. You write here 3 over 2 minus 1, okay, which is 1 over 2, okay, times the second one minus the first one times the second one's derivative, which is 2x, right, over x squared plus 4 to the 2, okay. So we have this quotient. You don't have to simplify it. So you have this. What about this? you know, the derivative of this function, you can see the first one as 4x to the 3 and the second one second x. So you have this 12x squared times second squared, second x, plus 4x to the 3 times the second one's derivative. We did that before, it's second times tangent. Okay, maybe you can memorize it to have easily the answers. Okay, but you don't have to. So finally you have this, and we write it in the parentheses of 4x to the 3 second x. So you get this. Okay, this was the last question. See you next week. If you want ask any question, you can attend the office hours, which is on Fridays between 5 and 7 p.m. So see you there. Take care.